Consider w to be equal to z over z squared plus 1, where z is a complex number x plus iy. Given that the imaginary part of w is 0, shows that the modulus of z is 1. So let's consider this w and just substitute x plus iy for z, so it becomes x plus iy, x plus iy squared plus 1. And to show something, we should use this only information, but to understand what is imaginary part, we should represent this w as something without I plus I multiplied by something also without I, hence its real part, its imaginary part. So we should get rid of I in the denominator. So we can open parentheses firstly, and it becomes x squared plus 2i xy plus I squared y squared. I squared is negative 1, so it's minus y squared plus 1. Let's rewrite it, and it becomes x squared minus y squared plus 1 plus 2i xy. And to get rid of y in the denominator, we consider this as one term, and we multiply by the same but with minus to get a formula a squared minus b squared. So it becomes x squared minus y squared plus 1 plus 2ixy multiplied by x squared minus y squared plus 1 minus 2ixy x squared minus y squared plus 1 minus 2ixy. And the denominator becomes x squared minus y squared plus 1 squared. Its formula a minus b, a plus b, so it becomes a squared minus 2ixy squared, and I squared is negative 1, so it becomes plus 4x squared y squared. And we can not open parentheses, let it remain the same, x plus iy, x squared minus y squared plus 1 minus 2ixy. And we need consider imaginary part equated to 0 and to get something, but what we actually need here, we need the modulus of z. But what is the modulus of z? By definition, it's square root of z multiplied by z complex conjugate, and if z is x plus iy, it finally becomes x squared plus y squared. So we need actually x squared plus y squared, and we can get it from imaginary part, which is 0. So let's consider imaginary part of w, and we need denominator becomes or is the same, but when do we get terms with I? We get it when iy is multiplied by this, so it becomes x squared minus y squared plus 1 multiplied by y, and when x is multiplied by this term, so it becomes minus 2x squared y, and other two terms give the real part of w, and it is given that it's 0, and fraction is equal to 0 when the numerator is equal to 0, denominator cannot be equal to 0, and we remember that we need finally x squared plus y squared, so that we then can find the square root. And since y is not a 0, hence it's not a root of this equation, we can just divide both terms by y, and it becomes x squared minus y squared plus 1 minus 2x squared is 0. It's minus x squared minus y squared plus 1 is 0, hence x squared plus y squared is negative 1. Just move negative x squared, negative y squared to the right, and hence plus 1 plus 1. So the modulus of z is square root of x squared plus y squared, and we can see that x squared plus y squared is directly 1, so it's a square root of 1 is 1 as required. And that's all for this question.